students?
But sir,
So just open where we are. Where we are last yesterday's class till where conduction is over. I think we have done some problems also, right? Based on conduction, objective numericals from our material also. Okay, so right, then we will go for convection and radiation. Students, convection is the theoretical one. We don't have any numerical question from the convection. Let us see what is convection, what are the types of convection, day-to-day life, what are the examples we will notice based on convection. Let us see, then after that we can go for radiation. Radiation, many small definitions are there. What is a black body? Such type of definitions are there. While going to the topic called radiation, everyone must pay attention towards the class. Okay? So it keeps updating a convention. Convection. What is mean by convection? Already we have noticed. Conduction is what? Process of transferring the heat without movement of the particles of the medium. That is called conduction. So convection means with the movement of the particles. With the movement of the particles, that is called convection. So note down that one. The process of transferring the heat. The process of transferring the heat. The process of transferring the heat due to the movement of the particles due to the movement of the particles in the medium due to the movement of the particles in the medium is called convection.
Repeat the sentence.
Yeah. Let me repeat this just to have a look on it, those who are written. The process of transferring the heat due to the movement of the particles in the medium is called or is known as convection. That is known as convection. Let us see this one, just an example of convection. We have taken a flask containing some water, and if the system is put it on a flame, then what will happen generally? Generally, what will happen means the flame is giving the heat energy to this flask containing water. Then what will be happen? Because here first the water molecules near the bottom of the vessel will be heated first, whose temperature will be increased first. Practically it is. So that molecule, the high temperature molecule will goes to the bottom. So it goes to the surface. From the surface onwards, low temperature molecule will move down. This process is continuous till the entire water temperature is brought to some constant level. Observe clearly from the bottom onwards till the surface how the heat is transferred. Heat is transferred due to the movement of the water particles from bottom of the vessel to the surface of the vessel. Here the heat is transferred from bottom of the flask to the surface of the top of the flask due to the movement of the water particles in this medium. Heat is transferred to this. This process of transferring the heat is called.
convection.
Yeah, convection. Similarly, room heaters are there. Is there or not? Room heaters.
Yes.
In olden days, inside the room there is an arrangement is there to have the flame also. In movies also you may have seen in Hollywood movies. How it will be means hot air molecule will be randomly moving in different directions in the room. So thereby the air is get heated up inside the room. There is also that heat is transferred from one part of the room to the other part of the room due to the movement of air molecules. So these are all the process examples of this is called convection. And one doubt I will ask a student: the candle flame is there, no candle flame or any wick is there, lamp, okay, oil wick. The flame will always about to burn up only. Generally,
Yes, sir.
in
Yes.
yeah, candle. This only the flame will be like this only. No? So why it will be always projecting up a flame is why can't be downward? Yes, that is also the air molecule which will beside this flame will be heated first. Those molecule will be moved upward direction. From the bottom onwards, the molecules of cold molecule will rush this hot molecule upward direction. Because of this reason, the flame is always upward direction. Here also, the heat is transferred to the atmosphere due to this movement of air molecules. Due to the movement of air molecules. So these are called convection. So convection means that there are got it student what is mean by convection, are you getting?
Yes, sir.
Students.
Yes, sir.
Yeah, so, yeah, convection. Convection means that here also the same thing. So here the air molecules beside the flame will be heated up, heated first. Those molecules will move upward direction. Its place is filled by another cold molecule. Again, that molecule after heated, it will be raises up. Again, it will be filled by another molecule. That's why the cold molecule will rush upward direction. The hot molecule will move upward direction. So because of that reason, the flame is always vertical. Not only this flame, any flame will be vertical because of this movement of the fluid or movement of the air molecule beside the flame. So here the heat is transferred to the atmosphere from this system due to this movement of the air molecule. This type of transferring the heat is known as convection. Similarly, here also, first the water molecule which bottom of the flask will be heated first. Those molecules will rises to the surface. From surface onwards, again the water molecule will goes down. So this process is continuous till this entire flask water temperature is attained a particular value. If we are keep on heating, means what will happen? So it is heated. After that, 100 degrees centigrade is reached. Still, we are supplying the heat means by gaining that energy, the water will be starts evaporating. Water is starts evaporating. So this is here the heat is transferred from bottom of the flask or from the point where we have kept the flame to the surface by means of this movement of the water molecules inside the water. So this process of transmission of heat and transfer of heat is known as convection. There are two types of convections are there. One is the natural convection. Natural convection. Second one is forced convection. Okay. Natural convection. Forced convection. So this is about two types are there. Natural convection, forced convection. So what is mean by natural convection means, of course, convection means the process of transferring the heat due to the movement of the particles in the medium. What is mean by natural convection means, okay, the process of transferring the heat in a medium by the motion or the movement of the molecule due to the variation of densities. Due to the variation of densities, the process of transferring the heat in a medium by the movement of the particles due to the variation of densities, that type of convection is known as natural convection. Forced convection means the forced movement of the molecule in the medium by means of any external agents or heat pump. That type of convection is called forced convection. That type of convection is called forced convection. Forced convection example is exhaust fan. Exhaust fan will rush the hot air from inside of the room to the atmosphere. So there by using that heat pump, we are forcibly dragging the hot molecule or hot air molecules inside the gas, and we are projecting those molecules outside the atmosphere. So these are called forced convection. A natural convection examples means land breezes, sea breezes. So before going to that land breezes, sea breezes, let us see what is the natural convection means. Okay. Sea breeze, land breeze is an example of natural convection. How it will be, let us go through this. So this is the ocean water, this is the land surface. During the daytime, both surface of the ocean and surface of the land both are exposed to the sun. By absorbing that radiation or energy from the sun, both of will be try to heat. Which one of them will be heated first means land surface temperature will be heated first because the specific heat of the surface land is less than the specific heat of water. The specific heat is more means that object will not easily heated and will not easily cool down. Okay. So if the specific heat is more means to raise its temperature it is a bit hard and to drop its temperature is also a bit hard. It can be heated slowly and it can be cooled slowly when the specific heat is more. Okay. So therefore, when compared to the seawater and land surfaces, the specific heat of seawater is more than the specific heat of land. That's why what will be happen means the land surface will be heated first. That's why the air above the land surface will be heated first, and its temperature is increases. When temperature is increases means density of air is gets decreased. You know that. So then density is decreases means low dense air will rises up to fill the gap, to fill this gap, air will blow from the surface of the ocean to the land. So this is called the sea breeze. This is called the sea breeze. Here the movement of the fluid is due to the variation of the densities or not. Variation of the densities. During the night time, what will happen means during the night time sun won't be there. So therefore, daytime both. So this ocean surface and land surface both are exposed to the sun and gets its temperature is increases. So because of the specific heat of the water, specific heat of water is more means it will take a bit more time to cool down. That's why land surfaces will be cooled faster and this surface of the ocean will take a bit more time when compared to the land. So then in this case, because of this temperature, the air above the surface of the ocean temperature will be more. So that's why here the temperature of the air is more than this means this is the hot air. So hot air will have less dense. So that's hot air will rises up to fill the gap. The cold air will blow from surface of the land to the surface of the ocean. So this is called land breeze. Land breeze occurs night time. Sea breeze occurs daytime. So here the movement of the fluid is due to the variation of densities of the fluid. This is type of convection is called natural convection. Understand this natural convection? So simple one is why those surface of the ocean or water surfaces will take a bit more time to heat up means because of the specific heat. Specific heat of the surface of the ocean is more than surface. Sea water is more than the specific heat of the land surface. That's why both are exposed to the sun means the sun giving the energy at equal rate by absorbing that the temperature of the land temperature will be more. Okay, will be increased faster. When this land surface temperature is increases fast means the air above the land surfaces will be heated first. When air is heated means what will be happen? It's become less dense. The less dense air will be raises up. So to fill that gap, the cold air will blow from surface of the ocean to the surface of the land. This is called sea breeze. During the night time, what will happen when sun is not there during the night time, but till the moment before going to fall, the sun is continuously giving the energy. Sun is continuously giving the energy. So therefore, till the moment before sunset, both the ocean surface and land surface were heated up by the sun. When the sun is gone, means because of the high specific heat, the water will calm down, will cool down slowly when compared to the land surface. Land surface will be cooled down very fast when compared to the water surfaces. That's why, because of that, the air above the ocean surface, temperature of the air above the ocean surface is a bit more. So, because than the air above the land surface, this is the hot air. Hot air is less dense. That less dense air will raises up. And to fill the gap, the cold air will be blown from surface of the land to the surface of the ocean. This is called land breeze. Land breeze occur night time, sea breeze occur daytime. So here the movement of the fluid is due to the variation of the densities only. So therefore the type of convection is known as natural convection. Got it? Clear, students?
Yes, sir.
Clear, sir.
Yeah. Any doubts you can ask?
No,
Students.
sir.
Okay, now?
Sir, here in daytime, the air that gets heated up, sir.
Which one now?
Sir, here in the land. Sir,
Yeah.
that air replaces the air in the ocean, or
Both are heated. Land surface air is both are heated, but because of the lesser specific heat here, the land surface will be heated first. Okay, or the temperature of the land surface will be increased first. This temperature is increases means the air above the land surface temperature is also increases. That's why this will become hotter. Then the hot air is less dense. That less dense air will be raises up to fill the gap here. Okay, some air is continuously flowing up means to fill the gap. Cold air will blow from surface of the ocean to the surface of the land. Because of the specific heat only, both are exposed to the same source of energy. But because of the specific heat here, much energy is needed to raise the water temperature. Here, less amount of energy is used to raise the temperature of the land by the same raise of temperature. So that's why here more air is heated means here the heat is mostly absorbed by the water. Here less amount of the heat is absorbed by the land when compared to this. Because of this, the remaining is used to heat up the water. Air. That's why the air above the land surfaces will be heated first when compared to the air above the ocean surface. That's the
yes,
reason.
that's good, sir.
Okay, so right, note down that convection. And one important point is two important points. Force of gravity plays an important role. If the gravity is not there, there is no movement of the air in upward and downward direction. If this air is not moving either upward or downward, means there is no chance of blowing the wind. See this land reason. Natural convection means force of gravity plays an important role. Natural convection will not take place where there is no gravity. Where there is no gravity, And one more important point is heating is done from bottom to top. Cooling will be done from top to bottom in case of natural convection. But whereas forced convection means it can be any order because it is made by external agent. Some external agent utilizes some energy to move the molecule from one place to another place. So that's a forced convection. Gravity is not required and it can be done in any manner. So heating can be done from slantwise up, slantwise down. In any manner, it can be done forced convection. But whereas natural convection means gravity is the important one. Without gravity, it is not possible to have natural convection. And in case of natural convection, heating will be done from bottom to top. Cooling will be done from top to bottom. So that is about the difference between the natural and forced convection. So these are only theoretical bits will be there. And in NCRP also regarding this, they have explained slightly regarding this land breeze and sea breeze also. Okay. No need to draw this one, already just to have an idea.
Sir?
Yeah.
Sir, even high dense air also moves up, low dense air also moves up, sir.
Low okay, lesser dense air will move up because of the density. I think still fluids not completed. No? That's there
No,
will
sir.
get regarding the density of the fluid. When the body is floating means why is the reason some bodies will sink inside the water, some bodies will float on the water.
Density is less.
High density means it will sink in the water. Less dense object
Yes,
will
sir.
float on
It will
the
float.
water. That is the reason
Water.
low dense air will rises up, high dense air will stick on the surface of the land. Clear?
Sir, whereas in second case it becomes vice versa, no, sir?
Second case here it is this will be cooled down. No? Land surface will be cooled down. No? The temperature of the air above the land surface will be calmed down first. When compared
Yes.
to the temperature of the air above the ocean surface, that's why this is the hot air, this is the cool air. Hot air will have high depths, that's why this hot air will be rises up, and this cold air will blow from here to there.
Okay, sir,
Here
understood.
also it will be calmed down first. That's why the temperature of the air above the land surfaces will fall first. Okay. Because of the here it is water is hot no, when compared to the land. That's why the temperature of the air above the water surface will be a bit more than the temperature of the air above the land surface during the night time. That's why because of that air will blow from here to there.
Okay, sir, understood.
So write it now. Natural convection. Natural convection. It is. It is. It is the process of convection. It is the process of convection due to. It is the process of convection due to variation of densities. Variation of densities of the medium, a fluid, anything you can write. Variation of the densities of the fluid or medium. Example, land breeze, land breeze. Example, land breeze, comma, sea breeze, monsoons, etc. These are the examples of natural convection. One note you can write.
Sir, land breeze, sea breeze afterwards?
Monsoons, season.
Okay, sir.
Okay, monsoons. Next, after that, one note you can write. Okay. Force of gravity plays an important role in natural convection. Force of gravity plays an important role in natural convection. Force of gravity plays an important role in natural convection. Next point, there only you can write. Next point number 2. Natural convection cannot take place. Natural convection cannot takes place. Natural convection cannot takes place. Natural convection cannot takes place in gravity-free regions or gravity-free spaces. In gravity-free regions or gravity-free spaces. Your wish, you can keep anyone. Next after this last one. Heating will done from bottom to top. Heating will done from bottom to top, and cooling will from and and cooling will from and cooling will from top to bottom. Top to bottom. Okay. Next, this is about natural convection. Next, forced convection. Forced convection. Forced convection. What is the forced convection? Write it. That is okay. It is the process. It is the process of. It is the process of forced movement of particles. Forced movement of particles. Forced movement of particles. Forced movement of particles by an external agent or heat pump. 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 Example, exhaust fan. Okay, exhaust fan. Next after that, so many artificial things we can say this one. Okay. So right, this is about the convection. There is no numerical questions from convection. Only theoretical questions will be there. Okay. So which type of convection will not take place in artificial satellites? Which convection will not take place in artificial satellites? There is no gravity. Gravity is zero. Okay, so
Natural convection.
natural convection will not take place. Which type of convection I am asking? Convection, not process. Which type of radiation will take place? Medium is not at all required. It does not depend upon anything. It will depend upon the source and destination distance. Okay. So natural convection. So then what is the order of the heating in natural convection? What is the order of the heating in forced convection? It can be any order. Cooling will be done in any order. Heating will be done in any direction. Okay. But whereas in case of natural convection, heating will be done from bottom to top. Cooling will be done from top to bottom. So this is about the direction of the cooling and direction of the heating. So right, coming to this one next, radiation. Radiation, keeps spreading radiation. Students here, so many small important definitions will be there like black body, emissivity, emissive power, absorptive power, Stephen's law, Weit's displacement law. These are some 9 statements are the simple statements. That's why be careful regarding the radiation. So just what is mean by radiation? Write it. Radiation. What is the radiation? We told that the process of transferring the heat. The process of transferring the heat without necessity of the medium. Without necessity of the medium. The process of transferring the heat without necessity of the medium. Without necessity of the medium is called or is known as radiation. Okay, radiation. Radiation. Called radiation. So next, thermal radiation. Thermal radiation. Thermal radiation. Thermal radiation. What is mean by thermal radiation means so note down this. Okay, note down. the emission of electromagnetic waves, the emission of the electromagnetic waves due to the expense internal energy, due to the expense internal energy in bracket function of temperature we can write.
Sir, can you please repeat?
Yeah. Okay. The emission of electromagnetic waves from the body. I wrote emission of electromagnetic waves due to the expense internal energy. Internal energy as a function of temperature. Due to the expense internal energy from the objects known as thermal radiation. Known as thermal radiation. Okay, known as thermal radiation. Okay, so
Sir, function of temperature from?
Function of temperature from the object. Function of temperature of this from the object or from the body known as thermal radiation. Just once go through that sentence what you have written. The emission of electromagnetic waves due to the expense internal energy. Internal energy is a function of temperature. If the temperature is more means internal energy is also more. If the temperature is less means internal energy is also less. Regarding the internal energy, we will see that the chapter called thermodynamics. So if the temperature of the object is more means its internal energy is more. Okay, if the temperature of the object is less means its internal energy is less. The emission of the electromagnetic radiations or electromagnetic waves due to the temperature of an object that is known as thermal radiation. Every body emits thermal radiation. Hot body emits hot radiations. Cold body emits cold radiations. For example, a cup of tea is there which is at nearly some around 80 degrees temperature, which are exposed to the atmosphere. What will happen? What will be happening means in what are the waste it loses the heat. It will loses the heat in two ways. One is convection because by heating the air molecules which are in contact with the cup of tea. Second one is it will emit the thermal radiation. It will emit the energy in all possible direction because it's expense of temperature as the temperature is increases. Okay. So there are nodes, so it will calm down. So that every body emits thermal radiation. Every body emits thermal radiation except at 0 degree Kelvin. Okay, except at 0 degree Kelvin, all the bodies emits thermal radiation. That theory also we will see that. So what is mean by thermal radiation means emission of an electromagnetic waves. Emission of an electromagnetic waves from the objects or bodies due to its expense internal energy. That internal energy is a function of temperature. So due to the temperature of an object, the emission of electromagnetic waves from the object is known as thermal radiation. That is called thermal radiation. Then what are the properties of thermal radiation means properties of thermal radiation means it will exhibit all the properties does the light will exhibit. What are the properties light will exhibit?
It moves in straight line.
5 properties are there. Okay, reflection, refraction, interference, diffraction, polarization. In 12th standard, you are going to study this. These are the 5 properties. In addition to that, rectilinear propagation is also there. Rectilinear propagation means light travels straight lines in a continuous medium. Okay, the medium is changes, the light will deviate its path. Without changing the medium, the light will continuously travels in the straight lines only. All the properties exhibited by the light, the same properties also exhibited by thermal radiation. The light can travel with a speed of 3 into 10 to the power of 8 meter per second. Even thermal radiation is also can travel with a speed of 3 into 10 to the power of 8 meter per second. Because of this thermal radiation only, we are getting the energy from the sun. Sun is a hot body or cold body? Hot body. So hot body. Yeah.
Nothing, sir.
So sun is a hot body. The temperature of the sun is much more than the temperature what we are expecting. That because of this high temperature, the sun emits the thermal radiation, electromagnetic waves in all possible directions in the space. So that electromagnetic waves from the sun due to its internal energy as a function of temperature, that is known as thermal radiation. That is called thermal radiation means emission of electromagnetic waves from an object or from a body due to the expense internal energy. Internal energy as a function of temperature, or in other words, we can say that the emission of electromagnetic radiations, EM waves, electromagnetic wave from the object or a body due to its temperature. Due to its temperature, that is known as thermal radiation. The properties of thermal radiation means thermal radiation will exhibit all the properties thus the light will exhibit. What are the properties does the light will exhibit? The thermal radiation is also will exhibit the same properties. Light can travel with 3 lakh kilometers per second in free space. Even thermal radiation also can travel with the same speed. Light will exhibit the properties of rectilinear propagation, reflection or refraction, interference, diffraction, polarization. Similarly, thermal radiation is also will exhibit all these properties like rectilinear propagation, interference. Thermal radiation can reflect, thermal radiation can refract, thermal radiation can diffract, thermal radiation can polarize, thermal radiation can interfere. So this is all the properties that will exhibit thermal radiation. So next one is previous theory of heat exchange. Okay, so this is no need to write. Just let me explain what are the important points are there in the previous theory of heat exchange. So let me write. Theory of heat exchange. Okay, no need to write this is just have a look. What is according to this theory means first points are what is the first point? Only 3 points are there. Okay, first point is every body emits thermal radiation except at 0 degree Kelvin or minus 273.16 degree centigrade. Every body emits thermal radiation except if the temperature of the object was at 0 Kelvin. If the temperature of the object was at 0 Kelvin, then at that state the body does not emit the thermal radiation. Except the temperature, all the objects will emit thermal radiations. Cold body emit cold radiation, hot body emit hot radiations. So second one is what is the second one? Then when the temperature of our body increases, means observe clearly. Okay, observe clearly. This is the ice. Okay, and which was placed in atmosphere. What will be happen means it will emit the thermal radiation as well as it will receive the thermal radiation also. It will emit the thermal radiation as well as it will receive the thermal radiation from the atmosphere. So then why the ice will melt means look at here. So the amount of the radiation emitted by the ice is less than the amount of the radiation which was absorbed by the ice. Okay, here the amount of the radiation which was absorbed by the ice is more than the amount of the radiation which was emitted by the ice. Because of that, the ice temperature will increases. The ice temperature will increases and ice starts melting. Similarly, when the temperature of an object will be decreases, means when the temperature of the object decreases, for example, hot water is there. This is the hot water tub. So then hot water tub means what will be happen here also the hot water will emit the radiation and from atmosphere it will receive the radiations also. From atmosphere it will receive the radiations also. So then in this case what will be happen means the amount of the radiation emitted by the hot water is more than the amount of the radiation which was received by the hot water. That's why the hot water temperature will be reduces. Here what will be happen here the amount of the radiation absorbed by the ice from the atmosphere is more than amount of the radiation which was radiated by the ice. Here, in both the cases, this ice is also emit radiations, hot water is also emit radiations. According to him, each and every object will emit thermal radiation except 0 degree Kelvin. Ice is at, let us say, 0 degree centigrade. I am telling you, the hot water is at 100 degrees centigrade. So even the ice is at 0 degree centigrade is also ice will emit thermal radiation. But then why the temperature of the ice is increasing and ice starts melting? The reason is this only. The ice will emit the radiation. The amount of the radiation, thermal radiation emitted by the ice is less than the amount of the thermal radiation which was absorbed by the ice. So here this is what will be happen means here in this case the amount of the radiation by the hot water is more than the amount of the radiation which was absorbed by the hot water. So that's why here hot water temperature is false and ice temperature will be rises. So these are the three points as there in Leo's theory of heat exchange. So students remember that every object, every body will emit thermal radiation except at 0 degree Kelvin and exchange of heat takes place with the surroundings. Except at 0 degree Kelvin, every body emits thermal radiation and it can exchange the heat energy with the surroundings. Either it may give the energy to the surroundings or it may absorb the energy from the surrounding. That is called exchange. When the temperature of the body increases means when the temperature of the body increases, whenever the amount of the radiation emitted will be more, will be less than the amount of the radiation which was absorbed. Then on such case, absorbed radiation is more, emitted radiation is less. Then on such case, temperature of the object will increases. Whenever the amount of the radiation which was emitted is more than the amount of the radiation which was absorbed, on such case, temperature of the bodies will fall. So these are the 3 points which was there in previous theory of heat exchange. Got it? So no need to write it. Just it is to have an idea about this. We are discussing that. Clear, students? Previous theory of heat exchange. Every body emits thermal radiation and it accepts 0 degree Kelvin and it exchanges the heat energy with the surroundings. Okay, so hot body emits hot radiations, cold body emits cold radiation. Then when the temperature of the object will increases, when the temperature of the object will decreases means whenever the amount of the radiation emitted by the object is less than the amount of the radiation which was absorbed. On such case, the temperature of the object will increases. Whenever the amount of the radiation emitted by an object is more than the amount of the radiation which was absorbed, on such case, what will be happen? On such case, temperature of the object will fall. So therefore, in the here emission is more, absorption is less means temperature will decreases. Absorption is more, emission is less means temperature will increases. That is only the two things. Okay, clear with students?
Clear, sir.
So right, this is about this. Next, keep subheading. Reflectance, absorptance, reflectance, absorptance, reflectance, absorptance. Reflectance, absorptance, and transmittance. Okay. Absorptance, reflectance, transmittance. Now just to have a look on it, I have taken an object. Okay. So let observe this Q amount of the energy is incident on it. Q amount of the energy. Listen. Now what are the possibilities here? Means some of the energy will be reflected back, isn't it or not? And some will be refracted, some will be refracted, and then what will be happen means here some of the energy is reflected, some will enter into this material. In that, maybe some absorbed by the material also. Let A is the amount of the energy absorbed. The rest of the energy, what will be there? The rest of the energy will be transmitted there like this. Is there any other ways are there? Look for it. Whenever the energy is incident on this material, then what will happen? This material may reflect some part of energy and may absorb some part of energy and may transmit some part of energy. Is there any another way? There is only the three ways out there. So, for example, some 100 joules of energy is absorbed here. Then what are the example? Some 10 joules of energy may reflected, some 30 joules of energy is absorbed. Rest of that 60 joules will be transmitted like this. So, therefore, from this, what we can write means the amount of the incident energy is always equal to the sum of the energies which were absorbed and reflected, transmitted. So then I can write R plus T plus A. So then if Q is taken, this side what can I write? 1 is equals to R by Q plus or else we can write R plus T plus A divided by Q. Then we can write R by Q plus T by Q plus A by Q is equals to 1. What is being mean by R by Q means fraction of the energy reflected, T by Q means fraction of the energy transmitted, A by Q means fraction of the energy absorbed. The fraction of the energy which was reflected from the medium or material, that is known as reflectance. The fraction of the energy absorbed by the medium or material, that is known as absorbance. The fraction of the energy which was transmitted by the medium or material, that is known as transmittance. Here we can write this is R plus T plus A is equals to 1. This R is equal to what can I write? R is equal to, we can write capital R by Q. This is the fraction of the energy reflected from this material. That's why this is known as reflectance. This is known as reflectance. And here A is equal to the fraction of the energy absorbed by this material. Then A is equal to, I can write, small a equals to, I can write Q divided by A. This is known as absorbance. And here it is T. So T is equals to, we can write T is equals to what we can write? T is equals to capital T divided by Q. This is known as transmittance. Okay. So this is about the reflectance, absorbance, transmittance. Remember this one. For example, let us say if R is equals to 1, R equal to 1 means then what are the remaining terms? T is equals to what? Here R plus T plus A equal to 1. If R is equal to 1 means what are the remaining? 0. So that implies T is equal to 0, comma A is equals to 0. R equal to 1 means that is called perfect reflector. That is called perfect reflector. 100% of the energy is reflected back by that surface. That is called perfect reflector. For example, if A is equals to 1 means, then we can say that A equal to 1 means R is equals to R equal to 0, comma T is equal to 0. What it means that this is the perfect absorber. It will absorb all the energies which were incident on it. That is called black body. That is called black body. Okay. Why? I think let us see this black bodies matter. So reflectance, absorbance, transmittance means to understand this one. Let us take a material medium of this. Let Q amount of the energy is incident on the material. Then what are the possibilities? Means here the possibilities are some of the energy may reflected back by this medium. Some may be absorbed by the medium. Rest of the energy may be transmitted. So hence the incident energy is equal to sum of energy reflected, energy transmitted, and energy absorbed. Taken this side, we got this. What is this R by Q stands for? R by Q stands for the fraction of the energy reflected. P by Q stands for fraction of the energy transmitted. A by Q stands for fraction of the energy absorbed. This is known as the reflectance. The fraction of the energy transmitted, that is known as the transmittance. This is known as absorbance. For example, if R equal to 1 means the remaining 2 is going to become 0. R equal to 1 means that is called perfect reflector. A is equal to 1 means so then perfect absorber, that is it absorbs all the radiations which was incident on it. So therefore R equals to 0, comma T is equals to 0, that is called a perfect absorber. Perfect absorber means black bodies are perfect absorbers. Okay. So have you ever listened to black hole? What is mean by black hole? Why it is a black hole they have named? Yes, it is. We want to see an object means first light has to come from that object. Okay, light has to come from that object. So here, are you able to see this piece of charcoal? How we are able to see this piece of chalk? The light is incidentting on the piece of chalk and it gets reflected from it, and that reflected light is incidenting on our eye, causes a sensation to our eye. Then only we are able to detect this object. So black hole means from light is also not possible to return back. That's why it appears black. Light is also not possible. So that is called it appears black. That's why it is called black hole. Black bodies are black bodies. This is perfect absorbers are called black bodies. So in the nature we will have only 7 colors. No? Isn't it or not? Nature. What are the 7 colors? V, I, B,
G,
G,
Y,
R. But black is not there. No? Isn't it or not? In the nature 7 colors, black is not there. But observe this mobile screen. This is a This is appearing black or not? Now why it is appearing black? We are having only 7 colors. V, I, B, G, or with G are 7 colors are there. Then why it is appearing black? Why it is appearing black means here tube lights are there now. So the energy is incident on it. It is absorbing all the radiations, but it is not emitting any radiation. That's why it is appeared black. That's why it is appeared black. Similarly here, look at here. Are you able to see this red color?
Yes,
So
sir.
now, why it is appearing red means it will absorb all the radiations which was incident on it. The molecules of this paint is emitting the red color, emitting the radiation of red color. That's why it is appeared to be red. So this is the reason black color means. Okay, so let us see that black bodies later. Okay, so got it this one, students.
Sir, there is no perfect transmitter, sir.
Perfect is not there, perfect absorbers are not there, perfect emitters are not there, perfect reflectors are also not there. Something about 96 to 98% closest approximation. Perfect is not there. Ideal concept is up to books only. Ideal concept is not there in day to day life. Ideally, it is not possible. Ideal black bodies are also not there.
Yes.
Closest one. Okay, like this. Right, so students have got this reflectance, absorbance, and transmittance clear, all of you?
Yes,
Emma,
sir.
Yes, sir.
yeah, so you can write this. You can write this. Yeah, write it. See the. This is R equal to, if you want, you can write it here beside the fraction of energy reflected. A equal to nothing but fraction of energy absorbed. If you want, you can write. Okay, this is the fraction of energy reflected. Similarly, here also we can write the same thing. Fraction of
Sir, it's not visible, sir.
no, first we'll finish this, then we'll return this. Is it completed?
1 minute, sir, I'm writing. Sir, can you tilt the board, sir, to downwards, sir. Okay, sir, thank you.
You see, here also you can write the fraction of energy absorbed. Okay, so here also we can write fraction of energy absorbed. Here it is fraction of energy transmitted. Fraction of energy reflected is called reflectance. Fraction of energy absorbed is called absorptance. Fraction of energy transmitted, that is called transmitted. On any body you can take this R plus T plus A must be equal to 1. So if A equal to 1 means to consider the sum constant, the remaining term must be 0. That is called perfect absorber. If T equals to 1 means to consider the sum constant, the remaining R and A is equal to 0. That is called perfect transmitter. R equals to 1 means to keep this sum constant, this T and A are 0. That is called perfect reflector. That is called perfect reflector. That's why we wrote. So if R equal to 1 means remaining term 0, this is called perfect reflector, and this is called perfect absorber. Okay. So students, now the time is 9 o'clock. So we'll see the remaining in tomorrow's class. Okay.
Okay, sir.
So
Okay, sir.
clear all of you students, is it?
Yes,
Clear,
sir.
sir.
Yeah.
Yes, sir.
Yeah. Okay, guys. See you on tomorrow's class.
Thank you, sir.
Thank you,
Bye.
sir.
Yes.
Thank you, sir.